Hi there, my name's Ben and I'm an automotive application specialist here in the UK, and today we are going to look at PicoScope 7 Automotive, the basics. So we are looking at very much stripping it right back to the very first downloading the software, looking at opening the software, and then actually looking at some very basic functionality. So it's going to be all about how to make that first measurement and get something on the screen. So without further ado, we'll make a start. So the very first thing we were going to do is download the software. So Pico Automotive or Pico Tech have two different sides to the company. So there's the test and measurement side and the automotive side. We want to make sure that we go to the automotive website. So this is www.picoauto.com. So this should be what the landing page looks like when you come to this website. We are going to head to the downloads page, and then we're going to start looking at the different options we have here. Now the basic recommendation is always to go for the stable build of software. There is an early access version, and that gives you a bit more information about some of the new features that may be coming, but it's an early access version for a reason, and obviously that's still going through a development phase. The stable version is the one that we want to be using, which is the one we can rely on. PicoScope 7 is, it can be operated with different operating systems. So there is a version for a Mac OS and also a Linux version. However, the vast majority of users out there will be on a Windows device. Now, in terms of laptop specification, it's often a question that is raised here on our support desk. And one of the things we want to make sure is that we have either a Windows 10 or Windows 11 PC. Now, bear in mind that Windows 10 is coming to its end of life, I think in 2025, so be wary of that if you're looking to upgrade. The majority of laptops out there now are all Windows 11, so we shouldn't have a problem. It does also need to be a 64-bit device. Again, the majority of laptops out there that you may look on the market will already be 64-bit. As a basic sort of, your minimum specifications for your laptop, definitely an Intel i5 processor or above. 8 GB of RAM is a sort of a minimum, again, but if you can go for more, great. Now, we sort of recommend, a colleague on our forum, so Randy is another colleague of ours in North America. He has recommended a 120 GB hard drive. May seem a little bit excessive, but I can assure you once you start capturing and making measurements with the software, you'll find that you will start to fill your hard drive up. Okay, so we're going to go for PicoScope 7, the stable, and we're going to look for Windows, and we're going to hit the download button. Now you'll see up in your download overview that obviously it is in progress. And once that download has happened, then we're obviously going to open that installer and it will run an executable to get the software now installed on your PC. I'm not going to go through that bit, it's fairly self-explanatory, and obviously there's a few things that you just need to tick as you would with installing any piece of software. Once that it is done, you will then find that on your desktop there are two icons, one for PicoScope 7 Automotive and one for PicoDiagnostics. We are going to be focusing on PicoScope 7 Automotive. This is like the scope software. PicoDiagnostics is a slightly app-based piece of software. It's where you will find a simple relative compression test, the battery test, and probably most importantly, our NVH software. Now, obviously, there's lots of information on that on our YouTube channel. So once we have the software installed, we're going to go straight ahead and double-click PicoScope 7 Automotive. Now, I haven't got a scope attached to the PC at the moment, so we're just going to run the software in what we call demo mode. So this will allow us to play around with the software as if we had a scope connected. So, let's open the software. The software is free as well, please remember that. It's free to download, and are any future updates as well. So the first screen we see is Connect Device. Now obviously, if we didn't have a scope, we wouldn't have something to connect. So we're going to go right ahead and just use the demo software. So click OK. Now the next thing that you're going to see is the guided test toolbox. From here, you can basically select the type of test you want to do, and obviously the software will pre-configure the software itself. So your time base, your voltage ranges, and all of that will be done for you. And then from there, you can start making your measurement. For now, though, we are going to minimize the guided test window, and we're going to take a look at the actual waveform window as we see it, so the physical software. Now, at the moment, if we look in the top left-hand side, we can see the software is running. So this is where we can start and stop the capture. So if I just stop that from running for a second, we can either use, obviously, the mouse over the button or the shortcut, which is the spacebar on your keyboard. If I start that running again, you'll notice the waveform count is going up, and it's going up quite rapidly. So we have 64 windows now of captured data. We'll come back to that shortly. Let's just stop the software again for a second and just take a look at this actual waveform window. So this is where our physical waveform, our signal, will be drawn in the software. You'll notice that there are two colours, so channels A and B, and they are active, and they're actively capturing a signal, or in this case, in our demo mode, it's just showing our two demo signals. If we look at the overall grid, you can see that it is partitioned up into divisions. So in total, from left to right, there are 10 divisions. If we look up in the top part here where it says 10 milliseconds per division, that is our time base that is spread out across this entire window. So when we say 10 milliseconds per division, we have 10 divisions on the screen, which means each of those divisions is worth 10 milliseconds. So if I have 10 divisions, I have 10 milliseconds, I have 100 milliseconds of total time on the screen. Realistically, that doesn't matter too much in your initial connection and initial setup. What we want to try and get the handle of is understanding how we relate 10 milliseconds per division to what we see on the actual waveform grid. Okay. If we now look at our actual vertical axis, now all I'm doing is I'm just using my mouse to hover over the edge of this, of the red axis here, and obviously on the blue side as well. You can do this for any active channel. Once you've hovered your mouse cursor over there, you'll see it's changed to a double-headed arrow, just here. We can now click and drag and move the waveform to make it more viewable. Now this is possible on any active channel that you have in this window here. You will notice that we have a zero line in the middle. You'll also notice that in the channel options, so the channel overview here, we've got plus or minus 100 volts for channel A, which is our blue waveform. What that means is I have 100 volts at the very top and minus 100 volts at the bottom. Yeah? These are bipolar ranges. It's not often that we need to use the bipolar part of the waveform. Where it is important though is if we're using a current clamp, for example, and maybe you've got it on the wrong way round, so we actually see this but flipped around the other way, it's inverted. So, now we understand our channel ranges, or our channel or our vertical axis. We will also notice that there is these funny little ruler marks at the top of each active channel. These are our rulers, and they allow some very simple measurements that we can make to the waveform. So again, if we hover over the top of that ruler there on channel A, click and drag, and you can place these anywhere on your waveform. You'll notice now that in the cursor it says a voltage value, or a value for relative to that signal, and also we now have our ruler overview. If I was to drag another ruler, so there are two rulers for each active channel, we now have the value from the first ruler, the value from the second ruler, and the difference between them, so the delta value. Now that can be useful for when you're trying to analyse certain parts of a waveform to give you an idea about voltage levels. So there's 2 rulers for each active channel. There are also rulers for the time. So down in this bottom left-hand corner, again, same thing, we click and drag out onto the screen, and you'll notice now that we have a value in time. So if I hover there, so 10 milliseconds roughly, and then I'll drag another ruler out and roughly drag it to about 50, and then obviously that gives us the difference between the 2 time rulers as well. Little tip, if we were to actually type the value in the ruler overview, so again just click on the white area in the overview and then manually add the value, it will automatically set the ruler to that position. Okay. Next up, let's just look at the channel options. So these are where you're going to be controlling the amount of the signal that you want to see. For the most part, the software will do this automatically. However, we may want times where we actually physically set those values. So by clicking on the lozenge, so a little tip again, anything with a white background that you see on the screen has a clickable element to it. So again, we have the start-stop button, which is on a white background, hence it's clickable. The Timebase, the trigger, the Waveform Navigator, and obviously these channel options here as well. So on here, this is where we're going to select our voltage range. Now, the software has already pre-configured this, so it's manually set this to plus or minus 100 volts. The reason being is if we drag a ruler down on our signal here, we can see it's on 56 volts, so it's above the lower or the next range down at 50 volts. So let's just show you what happens if the range isn't correct. So we're running again, we can see that our Waveform Navigator has gone up. If I set that to plus or minus 50 volts, we now have a channel over range. Yeah? Please be aware, this isn't going to hurt the physical scope, and we'll talk about the hardware in a second. However, we just see in this channel over range, meaning the signal is beyond the limit of the vertical axis or the vertical range that we've just selected. By setting the range to a higher level, then obviously we can now see the waveform on the screen. Okay. We'll just keep going across this screen for a second just so that we can see what the different options are. So now from channel options, we go to probes, and the probe menu lists all the different probes that you are possibly likely to use. Now, PicoScope, the Pico BNC Plus option, so the 4425A is the one we have here today. Whenever you use the BNC Plus accessories, the software will automatically know what you have connected. So for example, we'll take one of our current clamps, we'll connect it to channel A, and then what will happen in the software is it will populate that as that accessory probe connected. Obviously we're running in demo, so obviously that's not going to show up just yet. Where this is good to note though is that actually if you're using any of the pre-existing or previously existing hardware, you can still use it with the new software. DSP, digital signal processing. So previously this may have been something known as the low pass filter. It's exactly what that is still here. Now what that does is it will automatically remove any frequency above the limit that is set in this box. So here it's asked for 1 kilohertz, so any frequency in the signal above that value is going to be automatically removed. Now we can see here how it's had quite a big effect on the actual signal. The advice for any first time measurement, do not capture with low pass filtering active. Make sure it is switched off, and then what you can do is do everything once you have your capture. Okay, so capture it with all filtering switched off. The last part in this, the channel options, is the display section. So here's where you could actually change your channel name. You can change the color, and a couple of extra little features here are scale and offset. So offset is just the position on the screen relative to the 0 line. So you'll see the 0 line for channel A is right in the middle of the screen, hence we have plus 100, minus 100, means my offset is at 0. If I was to move this up one, so again, remember we're in 10 divisions, both vertically and horizontally. If I move that to 10%, it means I've moved that up one division. Okay. Scale allows you to change the value in that division. So at the moment it's set to 0 to 20 volts. If I now change the scale to 2, we can see now that's gone to 0 to 10. So it's now 2 times the original. Yeah? This can be really helpful for when you're looking for very slow changing or very small changes within a waveform. Okay, that's channel options. So next thing then, obviously the big thing with any sort of scope captures, it's all to do with the time. That's the difference between what we see with a multimeter and what we can use with, or do with an oscilloscope. We are now in control of the amount of time that we see visible on the screen. Yeah? Now currently the software will automatically default to 10 milliseconds per division. Now we'll just see what happens as we start to increase that time. So we can click on there, it's got a white background, and now we have the options to change our time base. So you see where it was before at 10, and then we go to 20, yeah, and we go to 50, and we can see how it's just seeing more repetition of the signal that we are interested in, yeah. There comes a point where the software will change how it's collecting that signal. So we often sometimes hear people call it block mode and streaming mode. So block mode, best way to describe it is a bit like you're taking a burst shot on your camera phone or any digital camera. Yeah? You press and hold the button and then obviously it takes multiple pictures very, very quickly. What happens here is that the signal actually gets put onto the device and then sent via the USB as a block of data. Now watch what happens when I move from this block mode to the next one. So we're now in this streaming mode. We are seeing the data being moved across the screen left to right. So basically the signal is now coming into the scope through the USB lead and straight into the software, hence the term streaming. Yeah. So those are the two different modes, and depending on the type of signal you're looking at will depend whether or not you want to use streaming, so 200 milliseconds per division and above, or block mode, which is 200 milliseconds or anything below 200 milliseconds per division. So we'll just flick between the two just so that we can see how they change. Yeah. Personally, when I'm taking a measurement for the first time, I will always be in streaming. The reason being is that you will always see something. Yeah? Now that's completely up to yourselves. It may be that if we just use the default settings when you start the scope up, we can still get a signal and we can still see it. However, play around with the time base and then obviously you can change the way you see that signal on the screen. Okay. Let's go back to the original 10 milliseconds per division, the factory settings. And we're just going to look at the next part, which is the trigger. So triggers are important in stabilizing a waveform on the screen. They're not something to be scared of. Like I said, it's automatically set up in the demo software, so you can manipulate that trigger to see how it changes or how you can find out how it works. So currently in the demo signal, with the first startup of your software, you will notice there is a trigger active. Now the trigger is highlighted by this little diamond, yellow diamond in the screen. Now if we open the trigger settings, we can see there are a number of options. So the first thing is to do with the mode. So none, auto, repeat, and single. The type is simple edge, and I only want us to worry about simple edge at the moment. The source, so what channel do you want to actually set the trigger to? You'll notice that only A and B are active at the moment. Yeah? So this is because channels C and D are currently switched off. If I was to just switch them on, so let's put them to plus or minus 400 there, and again these are demo signals as we've said before. And we'll just set that to those, and there we have our extra channels on the screen. Okay, so let's just, again, use the mouse to click and drag and move those signals around just to help make things a little bit more visible. And you can see now we have our 4 signals on the screen. Okay, so now when we go back to the trigger, you'll notice we also have the options for channels C and D now to set the trigger to. If we just focus on channel A for a second, so we'll just move those ones down. Actually, let's turn them off again just to remove some of the waveforms off the screen. So yeah, so let's focus on channel A and let's just look at the trigger. So you see now the threshold is set to 20 volts. So the threshold is the crossing point that we are expecting the signal to pass through in order for us to stabilize and fix the signal on the screen. The direction is in a rising direction, so it means the signal has to be going in an upwards or positive direction past 20 volts in order for the software now to trigger that signal. The pre-trigger is just how much time we want before the trigger is hit. So how much of the signal do we want to see before that threshold is met. So in this case it is set to 20%. Again, this is just the default settings when you first start the software. So let's run the software then. So we are now in our auto mode. Now auto is a bit more forgiving. It's possibly the first one that you'll use if you want to get involved with triggers. What it will do is if I manipulate this diamond just for a second, or even just use the thresholds here, you know, I've moved that trigger to a point that is now no longer met by the signal from the demo signal. Yeah, so we are not anywhere near. The signal is not getting up to 72 volts. It's not in a rising direction, so therefore the software can't meet the trigger. But what auto does, it just allows you a little bit of time to see if the trigger's met before trying to capture something. So again, just about helping you get to grips with triggers to begin with in order to make sure you capture something on the screen. Okay? Now if I bring that trigger back down to a level that it would meet, so maybe something like there, so 50 volts, we can now see that this image is stabilized and we have our Waveform Navigator obviously populating all of our waveforms. Now obviously in auto, we can see that even though we've got it wrong, we are still capturing something. See up the top here, the waveform is going 5 of 5, 6 of 6, 7 of 7, yeah? Now if I move to repeat, nothing happens, 0 of 0, yeah? Repeat is very much like a hard line. Have you met those trigger requirements of, in this case, 68 volts in a rising direction on channel A? The answer is no. So therefore, it will not display and it will not update to the next waveform. If we move the trigger into a level that it can meet, then absolutely fine. We can carry on. My advice, if we're using triggers, if I'm in this block mode, you know, this anything like 200 milliseconds or anything below 200 milliseconds per division, so we're in this burst shot mode, use the auto trigger, because even if you've got the trigger wrong, it will always show you something. If we're in streaming, so this 200 milliseconds and above, my advice would be to use the repeat trigger. Now the reason being is because it will always be streaming data in. So if I now move this trigger back out the way, so to remove that threshold above the signal, so we're now not hitting the signal, but you can still see that something's happening, yeah? So from there, we can obviously make the adjustments to meet the trigger, and then it will start collecting, okay? Okay. Hopefully that gives a little bit of background into triggers. What we're going to do now is we're actually going to set up on this vehicle. We're going to look at the ignition coil and how we can use the triggers now to actually help stabilize the image on the screen. So we're just going to reset. Now reset will basically apply the default scope settings. So this will be what we saw when we first loaded the software and opened it up. So if you get in a real muddle with anything, just hit that button and it will take you back to the beginning. Okay. So let's stop the software. What we're going to do now is we're going to get the scope connected. Let's just disconnect the current clamp for a second. We're actually going to close the software. So what I want to do is show you what happens when we initially have the scope connected and then start the software afterwards. So this is pretty much going to be how we're going to be using it when we're actually trying to use the scope to collect data and waveforms. Yeah. So scope will be connected via the USB lead. Please make sure you use the blue USB leads that come with the scope and not any others. Double click the software. And then what should happen is that the scope will automatically be detected by the software and just start the actual process. So it will bypass this connect device window because we know we've got a scope connected. And then from there we see our initial screen. So now we've got our guided test window. We'll also notice that on the front of the scope, the lights should be illuminated. Hopefully that's coming through. Oh. Go. So as before, we're just going to minimize the screen for the time being. Let's just get our heads around the software before we can start without worrying about the guided tests for a second. So we're on 20 milliseconds per division, which gives me a total time of 200 milliseconds. Yeah. So again, 10 divisions of time, 20 milliseconds per division, 200 milliseconds total time on the screen. If we're in 20 milliseconds, we're in this block mode. Yeah. And we'll also notice that there is no trigger setup. So these are the default scope settings now, not the default demo settings. All right. It's activated 2 channels for me. I'm actually only interested in one. So what I'm going to do is I'm going to turn channel B off. Okay. Now channel A, I'm going to use a current clamp. So this is a 60 amp BNC plus current clamp, which means we can just literally connect to the scope and the software will automatically know what's connected. And we should see now, we go to our channel options and probes. You can see now Pico BNC plus 60 amp current clamp. It's the only one available because the scope and the hardware know what's connected. This also means that it's much easier to now, because our units of measurement are now in amps as well. So basically there's nothing more to do. Very, very simple. All the zeroing and offset and calibration for the clamp is already taken care of with the hardware and software. So we will now connect up to our voltage or the source for the ignition coil. We will set the scope running. So again, I've done nothing except let it do its thing. Yeah. Now we'll notice now that actually it's flicking. Yeah, it's kind of not really sure what's going on. It's moving between plus or minus 1 amp, plus minus 2 amps. Yeah, and now it's sort of settled on plus or minus 1 amp. Yeah. The reason being is that whenever you start this off, it's in something called auto. So auto will automatically try and set the range based on the signal it's seeing. Now obviously if we've not got any current flowing through it, it's just picking up residual noise within the system. So we'll start the engine. And again we can see now that actually it's automatically now moved to a plus or minus 20 amp range. Okay. What we'll do is we'll just stop that for a second. We'll just switch the car off. Now we said earlier at the beginning, this Waveform Navigator, yeah, so this basically shows us the last 64 waveforms that were collected. So basically we can now go back in time. So if I scroll back through, we can see all the different waveforms from when we first started. We started the engine, we can see how the software is trying to change the range to get to the right one, and then obviously it settles on the plus or minus 20 amps, and then we can basically now just keep flicking through and finding the waveforms of interest. Okay. Now at this point, this is where we go, do we need a trigger? So, yep, we want to try and stabilize that image. If I move myself backwards and forwards through this, we can see how that waveform is moving around on the screen. So to set up a trigger, now we're in this block mode, remember, this below 200 milliseconds. So I'm going to use auto. That will make sure that even if I set it in the wrong position, it will still show me something. Channel A, it's the only active channel that we have. And you can see now it's automatically put the little yellow diamond down on the 0 amp mark. Okay? Now I'm just going to drag that up slightly because I want it to be in the right area for where it's definitely going to be crossed by the current. We're going to go to the 20% like we had in the demo signal. There are some key points here. Which edge or which direction do we want the trigger to be active on? So we can see in this rising edge, it's not particularly straight. So if we zoom in, yep, so all I'm doing now, let's go back through over zoom as well. So zoom with a mouse is just on the mouse wheel, or hover over the little magnifying glass in the top right-hand side, click, and then click and drag around the area that you're interested in. Zoom is a really, really important and useful tool that you will be using a lot. So back to triggers. So we can see here that actually the rising edge isn't particularly, it's not clean, is it? It's not a straight line. It's very much sort of curved. It's like ramp up, yeah? For triggering, the best advice would always be to find a nice straight, clean edge, yeah? So in this case, the trigger direction that we're going to trigger on is going to be in the falling direction. So current is going in the opposite direction, yep, so falling down. So basically we're asking the software now, we want channel A to be our trigger. We're in automatic. The threshold is 4 amps and it's in a falling direction. So this basically means we want the software to only draw the waveform when there is a falling direction past 4 amps, and that's when we want it to trigger. So again, we'll start the software. And again, we're in this auto mode. And we can see now that the trigger is up here and ready to go. One thing to note, and obviously, again, this isn't always the case, but if we just look here, currently, there shouldn't be any current flowing through this wire yet. But we can see that there's a little bit of a calibration error just on the current clamp. Now, the chances are it's where I moved it after calibrating it in a different position. So what we need to do is a very, very simple test check. We just go to probes on the channel options and click the 0 offset. And there we go. And now it's back to the 0 line. Just be something to be mindful of. So, as I said, we're in auto. So it is going to keep collecting as we're going along. So the waveform count is going up, irrespective of the fact we are not hitting our trigger threshold. Let's start the engine. We'll just let it settle so that it's on the right range. Again, this is all done automatically. I've not changed or not selected my range. You may find that it's actually useful once you have a stable image to select it. So if we wanted to hold this at plus or minus 20 amps, into the channel options, select plus or minus 20 amps, and you'll see this has now gone to manual. And as you can see, we have a triggered waveform. Yeah. So if we just decrease the time base, and what that's basically doing is allowing us to move in and look a bit closer at this signal. We can drag our trigger along so it's in a different position on the screen. And now we can see those waveforms as they're going along. Yeah. Now if I was to set the trigger to the rising edge, and just see how that changes the trigger positioning. and see now how it's flicked so that the trigger point is now on this edge in a rising direction. But you can also see how this part of the waveform is just jumping about a bit. This general rule of thumb, pick a nice straight edge where possible, and that will be the one that you want to trigger on. You may find that though in some noisy environments that actually you may get extra trigger points. So again, just be mindful of where the threshold is, and obviously if you need to adjust it, like we can bring that all the way up there and it's still triggering. Yeah. But also be careful that you don't go too high, that actually the signal isn't triggered. So if we've got something like this coil, the current might be alternating or might be changing. So again, give the software a chance. Somewhere in the middle, you'll get a decent, stable image. Okay. Right. What we're going to do now is we're going to set up and see how triggers can help us when we're trying to do multiple captures. So quite a common test would be to look at multiple signals, but actually there's a little tip we can do with current. So for things like ignition coils and injectors, they tend to have a primary or a common supply. Also, that's usually run off of a fuse. So in the case of this vehicle, we actually have a separate fuse for the ignition coils. What we've done is we've used this fuse extension. We've taken the fuse out, placed it inside of the holder, and then obviously then fitted this part into the actual fuse board. Now that allows us to have a big current loop and also a voltage tap if we needed it to. Where this is useful is if we have our current clamp now, wrap that around the extension loop, well now I'm seeing current generated from all ignition coils, but from one channel. So I'm not having to go to each individual one with 4 current clamps. The 2000 amp clamp in this situation, plus or minus 20 amps on the screen, so that's what the voltage, the current range we are looking at. This clamp is more than capable of doing that. This clamp is really good down to about plus or minus 5 amps. Now what we're going to do is we're going to use our trigger from cylinder 1, which is currently connected to the BNC plus 60 amp clamp, and then we're going to use that to identify each of the cylinders. So we'll add our current clamp to channel B. Again, BNC plus. So plug it in, it's automatically detected. The current clamp goes round the fuse extension, and then basically that is it, we are ready to go. To begin with, I'm just going to take the trigger off of channel A, just so that we can see how these signals look when when everything is in front of us. So, we'll start the software. Channel B is in auto, so again this is going to manually adjust when we're actually ready to and find the limit or the range that it needs to be on. Yeah, so it's somewhere between 10 and 20 amps. We know that it's 20 amps from the previous one, so we'll just go slightly higher and just hold that there. Now again, we'll just hover over the axis and just separate these 2 channels out. And then we'll move the blue one up slightly. So this is where triggers are really useful. We have a lot going on the screen. It's bypassing us really, really quick. So we want to stabilize that image. So if I do the same thing again, we want to go to trigger. We're in this block mode, so auto. It's automatically set channel A to 4.8 volts in a falling direction. So happy days. So what we're seeing in this top blue one, which is the coil from cylinder 1, and from channel B, which is in the fuse board, which is actually the current supply for all 4 coil packs. Okay? Now if I start to extend my time, put more time on the screen, yeah, so now we've got lots going on in channel B, yeah, but channel A is our fixed, our stabilised signal on the screen. Let's just have a quick look at what's going on in channel B first. So if we just use our zoom tool just to highlight just channel B. Okay, so we have the coil events for every coil pack on this engine. This is a standard 4-cylinder internal combustion engine with a normal firing order of 1342. Now the question is, how do we know which cylinder's which? So if we back out of our zoom for a second, we now know that this is cylinder 1. So these two images here should be identical. Yeah, they should be the same, it should be the same pattern. And if we zoom in, yeah, sure enough, yeah, pretty identical. Yeah. The next one along though, so let's put a ruler out here for a second. So this would be cylinder 1. Well, if I have my firing order, the next one along would be cylinder 3. Cylinder 4, cylinder 2, back to cylinder 1. So now we're starting to see how we can utilise, especially with current loops, for sequential firing actuators like injectors and ignition coils. We now have triggers. They are helping us stabilise on the screen whilst also giving us something to actually reference to when we're doing our firing order sequence, for example. And we're now also seeing how Timebase can change how much of the signal we see compared to how much we don't. Okay. Finally, the most important part whenever we're doing waveform analysis, and it's something that I haven't even done, and it's very bad of me because we should be doing it every time we make a capture, is saving. So under save, there is lots of information that you can fill out. The first thing that we're going to be interested in though is locating a folder or putting a folder path in. So for me, I would always just go straight to the desktop. Maybe don't even call it a file name for a second, just click select. So that is where we want to put all of our files, is on the desktop. Alternatively, you could create a new folder and call it whatever you want. So we'll just call that test. Double click, and now basically every time you save a file now, it will automatically get dropped into that folder. From here, you're going to want to fill out some of your vehicle information. So this is a car, it is an Audi, it is an A2, and obviously the rest of the information can be pre-populated as well. We do have another video on the waveform library, and it will go through some of the information that is required in order to upload to the library, but we're not going to go into that right now. Once you have all of this information saved or selected, you then want to click Save. Final little bit of advice. You can see at the moment we have a saving file of approximately 22 megabytes. It's quite a large file. To help with streamlining this, you have some options. We can either click Current, so that saves this current waveform, which is 27, or we can select a range. So maybe your waveform you're interested in is between waveform 10 and waveform 20. Then obviously you can select your range, which again will change the file size. If in doubt, just save everything, and then you can always amend it afterwards. Click Save, and then obviously that will get saved to your folder path. Okay. All right, so that's a very, very basic introduction to getting something on the screen, some of the controls within the waveform grid, and obviously we've looked at triggers as well. So triggers are there to help stabilize the screen. As we mentioned, the two time bases, or the two different ways the scope collects the data, the block mode, which is anything under this magical 200 milliseconds per division. So anything below that is this block mode, this burst mode. Anything 200 and above is the streaming mode, so it will show you things changing onto the screen as they are happening. We've gone through save, probably the most important thing that you can get going. So once you've saved your waveforms, therefore you can always go back and reevaluate them and process them after you've made those captures. Right, that's it for part one. There will be a part two where we'll go into some of the other details and functions within the software, but hopefully that should get us up and running and start us getting capturing. Thanks for watching.